10.6 is called polar coordinates. The little half sheet that you got on your way in, that last problem, is going to help you understand the idea of polar coordinates. Okay, so currently, here's how we describe a location or a position. Okay? If you get an X and a Y, everybody knows what position or what point we're talking about. Okay, and that looks something like this. You go right or left X, right? So let's say we're here. You go up or down Y. And then we say that this point is positioned or located at X comma Y. Okay, these are called rectangular coordinates. X's and Y's are rectangular coordinates. The name comes from the fact that the points are positioned at the corners of rectangles. Do you guys see that? This is an X by Y rectangle. Here's the position. Okay, so that's why we call them rectangular coordinates. Okay, now, this is not the only way to describe a position. Okay, this is one of the most basic ways to describe to someone how to get to a position. You know, you go west 5 blocks, go north 3 blocks, there's my house, that kind of deal. All right. Another way to describe a position is using polar coordinates. And the idea is, instead of an X and a Y, you're going to be given a radius and an angle. Much like that third problem in the warm-up. Okay, and if you want, okay, you can use this little sheet as we do some of these graphing problems real quick. Okay, so for example, if I asked you to graph the point 5 pi over 6, okay? First, I mean, there's a few ways to do it. Here's the way I like to do it. I start with this angle, okay? You guys are familiar with these angles, right?
Yeah.
Where's pi over 6? Is it the first, second, or third one? It's the first one. So let me highlight that. So this is pi over 6, yeah? And then all we do is, in that direction, we go out 5 units. And you see, now you got those pretty little circles that actually mark it off for you. Does that make sense? So we go out 1, 2, 3, 4, 5. Here's the position, or the point, 5 comma pi over 6. Are there any questions on how I graph that?
And do you do it for all 4?
What do you mean all 4?
All 4? All 4 like sectors of the circle.
You mean quadrants?
Yeah.
Well, no, because that would be a different position then, right? So if you're talking about over here, that would be like 5, but now it's not pi over 6. What angle is that? That'd be 5 pi over 6.
Is there a way to show it where you can go around the circle?
No. It's just literally, you're given an angle and you're given a number. If it's positive, you go in that direction. If you were to get a curveball, like you will in a few seconds here, and I give you a negative number, instead of going in that direction, what would you do? You go back that many spaces, that many units. Okay? So try these 3 on your own. Okay? Graph these 3 coordinates. If you want, you can do 3 separate graphs. If you want to do them all on the same one, that's cool. Let's try 2 and then negative pi over 4. 2, 7 pi over 4. And then negative 2, 3 pi over 4. Okay, so take a minute or two, think about what we just did. Find where that angle is, and then travel out in that direction or back from that direction, depending on what the radius is. Let's see where we're at. Okay. Anybody notice anything?
Yeah, they're the same.
Everybody getting that? They're all in the same spot? Okay. If you're not sure or if you messed one up, negative pi over 4 is down to the middle, the second line, right? So that's this one. And we go out 2 units. So here we are. 2, 7 pi over 4. Well, if I do 7 pi over 4, I rotate counterclockwise, and I actually end up on the same ray. Does that make sense? So I go out 2 units, same spot. This one I go to 3 pi over 4. 3 pi over 4 is right here, right? But what do I do instead of going out positive 2? I go
Negative.
back, same spot. Does everybody understand? Okay. So what do we get from this? Basically, you just need to know that there are infinitely many ways, or infinitely many points that describe the same location. Yes?
I thought we had 3 pi over 4 to go counterclockwise.
It's positive, though.
Yeah,
So we go 3 pi over 4.
that's 3 pi over 4.
Yes, it is. Where else would 3 pi over 4 be?
My bad.
Were you going the other way on accident?
No, I thought it was something else.
Oh, okay.
Wait, I have a question.
Yes.
Okay, so because like the way I thought of it, like in my head, was I went over negative 2, and then since I know that 3 pi over 4 is like 190, and then like 2 lines away, then I went to negative 2, and then I went 90, and then 2.
Oh, I see what you're saying. So you, okay.
Like,
So you went 2 first this way, and then you went to 3 pi over 4?
no, like,
You sure?
yeah.
Okay. I mean, it's. I see what you're saying, but if you always want to find the angle first, and
I
then,
can't just count.
yeah. Okay. I mean, if you count off like 2, then all that tells you is that your point is going to be somewhere on this purple circle that's 2 units away from the origin.
So we go like start.
Yeah, well, we always start on the positive x-axis, and then we do the usual, if it's positive, we rotate counterclockwise. If it's negative, we go that way.
Wait, so why is it the right side?
Negative. Right?
What do you mean right side?
Like in my other line like this. Why is it
Here? Why isn't it here?
No, why isn't it up there?
Why is it here?
Why, yeah. No,
Well-
why isn't it there?
Because in that particular point, we had a negative 2, so we go back instead of forward in that direction. So like if this were positive 2, I'd go to 3 pi over 4, and then you go out 1, 2 in that same direction. But because the 2 is negative, you just go backwards 2 units.
Why wouldn't you do the negative 2 first?
well, we just went over that. If you go -2, these are not like x and y coordinates. You don't travel left and right. You have to go a certain angle and then a certain radius out or in or backwards from that position.
If you and I go 2 first, you get the same thing. Anyway.
What's that?
If you go -2 first, you're still getting.
If you go -2,
That is your 0 negative 3 pi over 4.
3 pi over 4. Oh, so from here you rotate 3 pi over 4? I guess you can do it. Yeah, if you make that a consistent thing, yes.
It's like doing the y-axis and then the x-axis.
So if you, okay,
Exactly.
so if you do -2 first, then from here you'd have to add 3 pi over 4. Does that make sense?
Basically,
Yeah.
Okay, so you can think of it that way too. Yes?
you're going too fast, right?
No, it's too slow because when he gets it, he just falls asleep, right? All right. Are any questions on this? Yes.
Would saying -2 comma negative pi over 4 be the same as 2 comma pi over 4?
No. Good question though. So let's look at it. You said 2 comma pi over 4. That would be rotate 45 degrees, go out 2 units, right?
Yeah.
So right here. And what was the other one you gave me?
-2 comma pi over 4.
So you go negative pi over 4, but then you're going to, which is here, but we're going to go backwards 2 units. Does that make sense?
So there's no way you get the same number in the same reference angle and what with different signs and so they're going to be the same.
Like this? No. Yeah, it's got to be
A different reference angle.
It's got to be 180 degrees away. These are not 180, they're like 90 apart, which is why it didn't work. Okay? Are we good? All right. Now, we're not going to do much navigation, but if you're wondering where the heck does this actually pop up, okay? You guys familiar with like radar or sonar?
Yeah.
Okay? What those do, if you've ever watched the movies, they have a little thing, and if you watch it, it kind of spins out. And as it detects something, what does it do?
It shows a dot.
It beeps when it hits that dot, right?
Yeah.
It spins around and then boop, and it keeps doing that. So what does it tell you? It tells you exactly this. 100 degrees from your position, you got something that's 5 miles away, or whatever the case is. Okay, so that's where this pops up. We're not going to do much of that. We're going to do, obviously, more just basic introductory stuff, getting used to how this works. Okay? So can we all handle first objective, graphing polar points? Okay, let's go on to the next objective. Don't make fun of my boops.
Your boots?
Boops. Boop.
No, I said
I don't have any boots. Although my parents did like to dress me up like a cowboy when I was little. That was good times.
Is that true?
Yeah.
Yep.
I had a little hat and I don't have any pictures
No,
now.
you got pictures. We all know you got pictures. Bring them in.
I know.
Did you just say everything about my life is sad? What?
Come on.
He had a very promising rapping career,
Go back to sleep or something.
Everything you say, she's like, that's sad.
That is
Oh, Colleen says that's sad. I see.
No, he just called her like
She does make fun of me a lot. Yeah, it's okay. Okay. Before we start seeing how these can be converted from one to the other, let's look at the relations between rectangular and polar. So what we're going to do, and stay away from your polar paper. We'll just use notes here on your notebooks. We're going to try to imagine an XY plane, but also right on top of that, polar. Okay, so what I'd like for you guys to do is put a point at x comma y. Obviously that means that we can go right x, up y, and that's where our point is. Now, if we wanted to do this in polar, you would be told to do what? Start here and rotate an angle. So let's do that. Draw it in. And once you've rotated that angle, do what?
Count the spaces.
Yeah, count or go out what?
The rectangle.
The radius.
What was that
Okay.
to? Go out the rectangle. So that's
So now, here's what we can do. Draw a right triangle in here. And using some basic tricks, some SOHCAHTOA, we're going to find the equations that you need to know to convert from one to the other and back and forth. Let's start with cosine theta. Cosine theta in a right triangle is what over what? Adjacent over hypotenuse. Very good. How long is the adjacent side here? X. How long is the hypotenuse? R. Very good. So X over R. Can we get X alone easily?
Yep.
So what's X? Let's write it as R cosine theta. Okay, Kevin, how do we get sine theta? What's that going to be? Which is? How long is the opposite? Thanks, Kevin, number 2.
Oh, you were asking Kevin?
Yes.
Oh, sorry.
What's the hypotenuse? R, very good. So can you tell me what Y is? How do we get Y by itself?
Oh, R sine theta.
Good. So there's another equation. Why not do a tangent one? This will come in handy later. Tangent is what over what? Opposite over adjacent. Good catch. Y over X. Leave it like that. That's fine. And there's one more very basic one. For a right triangle, what do we know about the legs and the hypotenuse? X squared plus Y squared equals R squared. Very good. It's not a contest. Okay. Are there any questions on how we got these equations? Okay. These are your links between rectangular, polar, to convert points, positions, and equations. Okay, it's not, you don't use any different stuff. It's these 4 right here. So let's look at an example or two. Let's say we want to convert 4, negative 4 into polar coordinates. No, you don't have to plot it. Okay? 4 and negative 4. This represents a what and a what? An X and a Y. Very good. This is an X. This is a Y. We want to end up with a what and a what? A radius and a theta. Very good. So let's look at our 4 equations here, our links between polar and rectangular. How can we find R? Is there an equation that's pretty easy to work with to find R? Yeah, the Pythagorean relationship. Very good. So since x squared plus y squared equals r squared, when I plug that in, I get 16 plus 16 equals r squared. 32 equals r squared. Square root it. R is going to be 4 square root of 2. So far, so good? Okay. Now, you have several options to find your angle. You could do r cosine, r sine. This one's a little easier, though, because it just works with y's and x's only. So to find the angle, I would do tangent theta equals y over x. You mean up? Sorry, I was trying to... So here's the equation we're using. Plug in y, plug in x, we get negative 4 over 4. So tangent of theta is negative 1, and yeah, you got to know your trig. You got to figure out what angle produces that tangent.
3 pi over 4.
Is there another option?
7 pi over 4.
Very good. Now we have to make a decision. Here's how we can do that. What quadrant is 4, negative 4 in? 4, negative 4 is in quadrant 4, right? 3 pi over 4 would get us to quadrant 2, which we don't want to do, right? We want to end up down here. So which one do we pick? We use this one. So then our answer is going to be what radius? 4 root 2, and our angle is 7 pi over 4. Yes?
Why do we say 3 pi over 4 this morning?
Because based on the original point, this tells us to go right 4, down 4.
Oh.
So we're in quadrant 4. Does that make sense? Good question. Let's try another one. Let's say we want to convert 7, 150 degrees into rectangular. So currently, this is a what and a what? A radius and a theta. We want to finish with an x and a y. So if I look at our equations real quick, is there any equation that tells me x equals and y equals that I can just use real quickly? Yeah, right here, these first two. This tells me exactly what x is. All I do is plug in r, plug in theta. We're done. So let's do it. We know that x is equal to r cosine theta. R is 7. And then we want to do cosine of 150 degrees. Cosine of 150, x coordinate at 150 is
1 over 2.
1/2.
Isaac?
Whoa,
Good job.
You're on fire.
I was close.
You were. Other one.
Yeah. Close. I didn't say root 2 over 2.
Yes, you were closer this time. That's good. So the x coordinate is negative 7 root 3 over 2. Does that make sense? Let's find y. Now I hope everybody can tell me what the sign is going to be. Plug in r, 7. Plug in theta, sine of 150. What is the y coordinate for 150 degrees in the second quadrant?
1 over 2. It's
150 is before 180, right?
1 over 2.
It is 1 over 2 this time. Good.
Man, that's good.
So answer is 7/2. So our answer, our x and y coordinates, running out of purple, sorry. X is negative 7 root 3 over 2, and y is 7 over 2. Okay, we're not quite done. We have a little more, so here's what we're probably going to do tomorrow. Tomorrow